Okay, for the last demo, we're going to mix it up. We determined in the first demo that agua frijo, cold water, was more dense than agua caliente. In the second experiment, we determined that water with salt dissolved was more dense than water with nothing dissolved. Do you think salt water would be more heavy or less heavy than fresh water, considering the polar properties of the water molecule? Remember, they dissolve salt because they can hold on to it. So we actually are adding mass. So the salt water would be heavier. And then also when we think about the temperature of the water, if the water molecules are expanding because of the heat, we've increased the volume. So therefore we've decreased the density on that level. So our last test is this. We're going to go warm salt versus cold distilled. So who has the greater effect on density? And what's your guess? Do you think salt water has a greater impact on water density? Or do you think temperature has a greater impact on density? Salinity, temperature. Salinity, temperature. So for this one, I am going to go with, since I'm doing salt, warm, I will go red. And again, you might consider the viscosity, the relationship now between density and viscosity. As water is more dense, it becomes more viscous. And we will look at the cold, fresh, and I will use blue, azul, to measure that. And so you can see they both are kind of slow getting spread out. So for this one, I'm going to let that spread out for a minute. And this time, I'm going to, as we wait for this, I'm going to use the cold, fresh on top of the warm salt. And we'll see if they mix, and we'll see if I can do a better job of getting these things inverted without the big spillage. Oh, yeah. Wow. That is well done. Now check this out. We get a thermohalocline. We get both. We get an inversion of both. We get the stratification of both temperature and salinity working together. Remember, this is warm. This is cold. So, but we still get. So what can you say right now? Temperature is warm. So we found that cold fresh definitely was more dense than warm fresh. And so now we have cold fresh on top and we have warm salinity. So let's flip this guy over and let's see what happens. Damn, I'm good. All right. And let's give this a minute. And so now I've got the warm saline on top. And one thing that I'm noticing right now is that we're starting to get mixing. It's a slow mixing, but if you look at the top flask, it's starting to go purple because the warm saline, even though this is cold, the warm saline is more dense. The salinity is pushing down red into the bottom and pushing up the blue into the top. And if we let this go for a while, these will be fully mixed. So what we found is salinity has a greater effect on water density than does temperature. So as we learn about currents, we're going to be looking at these factors: salinity and temperature and their effects, because the water is in motion because of differences in density. I hope that was helpful, and the observations you can now do if you haven't done yet. All right, adios.